Good day, everybody. Welcome to the Frost Implementers Roundtable. It's November 8th, 2023. I'm the host, and I'm representing Blockchain Commons. What is Blockchain Commons? We're a community interested in self-sovereign control of digital assets. We bring together stakeholders to collaboratively develop interoperable infrastructure. We design decentralized solutions where everyone wins, and we are a neutral, not-for-profit to enable people to control their digital destiny. And we are, as a nonprofit, not-for-profit, sponsored by a variety of different organizations. These are some of the more significant ones. We're going to begin with just some brief personal introductions. I'd like for you to say who you are, what is your association with Frost, and but save any project status things for later in the agenda. And in particular, I would like you to answer one of these questions. What do you love the most about Frost? What's been the most difficult? What was the biggest roadblock? Or what's coming up as your biggest concern? Just pick one and just share it with us. I will begin. I'm Christopher Allen. I'm Principal Architect and Executive Director of Blockchain Commons. What I love most about Frost is the opportunities to do interesting things with quorums, and do it in a cryptographically trusted way rather than relying on some post that such and such was true, to be able to do it cryptographically. Jesse, why don't you go next?
Yeah, I'm Jesse Posner. I've been working on a SecP 256K1 implementation of Frost. I've got a PR open in the SecP-CKP repo, and I've been working on it with Tim Ruffing and Jonas Nick. And there's a lot to love about Frost. I think one of the things that I'm most excited for right now is how it can impact recovery flows. So, for example, if you have a 203 wallet, instead of having to pay a high transaction fee when you recover funds and need to sweep all the UTXOs, we have these really cool rotation mechanisms using proactive secret sharing. We also have enrollment and disenrollment, share repairability. And so I think it can make for these really flexible quorums, and quorums that can easily recover funds without paying any fees and without having to go on chain at all.
Thank you. Conrado?
Hi everyone, I'm Conrado. I'm a cryptography engineer at the Zcash Foundation. I've been working with Frost mostly on a Rust implementation of all the cipher suites that are specified in the RFC. I've been also helping a little bit with the RFC, finding some small issues and fixing some of them, but I'm not one of the RFC authors. And now I also involved with the NIST submission of Frost for the threshold call for threshold schemes. I think the difficult part about Frost is not actually Frost. Frost is kind of it's fairly straightforward to implement, but the hard part is getting deployed. So we've been thinking about, in our case, our scenarios about Zcash. So we would like wallets to provide some functionality for people to be able to protect an account using Frost. So how you get it deployed? How do you make wallets talk to each other? Stuff like that. It's just engineering. It's not even cryptography, but that's actually the hard part of getting Frost deployed. That's it.
Shannon?
Hey, I'm Shannon Appelklein. I'm the technical writer here at Blockchain Commons. And what I love about Frost is its improvements for resilience. in wallets that we can deploy. Not just the fact that we can use multi-sigs to allow people to not just lose a key and lose their wallet, but also VSS in particular, so that we can make sure stuff is still out there without actually having to reconstruct keys. So that's all very exciting, and I think will be, if we can get people to deploy it, a whole new frontier for wallets.
Thank you. Ian?
Yeah, I have to unmute, I guess. Hi, I'm Ian Goldberg. I'm one of the original developers of Frost, and I've been involved in the IRTF RFC process and will be involved in the NIST process.
Thank you. Oh, you have something you want to say about Frost in this list?
What coming up is the biggest concern, I guess. If you're not familiar with our next work, Storm, which is up on ePrint, and we'll be submitting it soon. It's a new key generation scheme that is appropriate to use with Frost. Oh, and this is Luna. Luna is also involved.
Okay, Chelsea.
Cool. Yeah. Hi, I'm Chelsea. So yeah, I've worked on Frost, as well as like some of the standards efforts as well. Yeah, Ian and I both work together, and I'm excited to see kind of the community coalescing and finding Frost to be useful. And yeah, I'm just kind of curious to listen in today. So yeah, today I'll mostly be listening and hearing about, I guess, some of the development efforts. So
You want to share one of the icebreakers?
I guess, yeah, I think, yeah, mostly I guess like what's difficult for me about Frost is just understanding like, yeah, what's going on in the community and like what people are doing. So that's why I'm excited about this roundtable to hear what people are up to. So yeah, thanks, Christopher.
Thanks. Lucas.
Hello, I'm Lucas. I currently work for Penumbra. I've been implementing Frost on and off since it was not an RFC back in 2021. And currently we're sort of exploring implementing it as part of Custody and Penumbra. I'd say the thing I like most about Frost is that it's easy to implement. We've done it a few times.
Great. Wolf.
Hi, I'm Wolf McNally. I'm the lead researcher for Blockchain Commons. I've been a working engineer for over 40 years. I've written a lot of our published specifications and example code. My major concern for Frost, which is a lot of things, is making it very kind of human-oriented, easy to use, making it so that people find it natural to adopt. And I'm not a cryptography expert, so I often need things like that explained to me like I'm 5, but then I think that's actually good because I'm a good test case in that case. But I other than that, I have a lot of technical skills.
Thank you. Lucas.
You already won.
Oh, sorry. Tim.
Hey, I'm a cryptographer / cryptographic engineer at Blockstream, and I'm involved in let's say Jesse's implementation because I'm a maintainer of the libsecp 256K1-CKP library, Blockstream fork of the SecP library that's used in Bitcoin. And also, I'm a co-author of a recent paper at Crypto where we analyzed a variant of Frost, including a DKG. And at the moment, I'm also involved in a standard for the draft standard for the Bitcoin community, where we try to come up with a usable DKG standard. And for the icebreakers, I think this really, if you if you ask me what has been the most difficult about Frost, I think the most difficult part is the DKG. No one wants to talk about it, and we all talk about how nice signing is, but DKG is not that easy sometimes.
Thank you. Pili, I'm not sure if I'm pronouncing that right.
Yeah, that's great. I'm Billy. I'm from the Zcash Foundation as well. I'm the engineering manager, and I'm here mostly to listen and learn with a product hat on, because we want to help wallets integrate Frost for Zcash, and I guess that leads into my biggest concern, which is the user experience of this and what the user workflows are going to be. Things like VKG, also like Tim, and yeah, looking to learn today.
Thank you. Nat?
Hi, sorry, my daughter walked in my room and I had to shoo her out. Yes, so I work at the Zcash Foundation as well with Pili, Chelsea, and Conrado. I'm an engineer working on the Rust library as well. In terms of, yeah, I guess biggest roadblock is less that we've overcome and more what we're like trying to overcome now, I guess, is sort of what other people have said, just like getting it into the hands of users, basically. I think it's very versatile, but we just, yeah, want to actually have people, you know, using it, finding it useful. So
Thank you, everybody. Did I miss anyone? Don't think so. Okay. So project introductions. So we have, you know, and I think I may have misnamed some of these properly. We have a, reminds me, we have a notes document here that is collaborative, and any of you are able to edit. So I will put that in the into the chat here in Zoom. So I was trying to just capture, you know, what are the repos and other stuff that different people here are involved in. And also there's an opportunity for people who want to edit and have notes, they can add them to the bottom. But I wanted to basically walk through the different projects and have someone, you know, talk a little bit about what is your current progress, what's next on your roadmap, security review situation, and then sort of related standardization efforts. We've heard, you know, about IETF and NIST and Bitcoin, et cetera. So let's begin with the Zcash Frost. Who wants to speak up to kind of share the status of that?
I can talk about it. So basically we have this repo that has a implementation of all surface suites in the RFC. It has been audited. The audit has been published two weeks ago, something like that. And we probably publishing our 1.0 RC0 release this week, probably. So kind of finishing up the main part of our work. And what's coming up next, we have another repo that has like a demo for how to explain how to use Frost, to show how to use Frost programmatically. I'll put a link to the repo in the HackMD. Right now it works like we have to copy and paste JSON blobs between terminals to fake communication. And what we're working right now is actually doing socket communication to actually make work of the network. But that's like still just like a proof of concept. Our final goal is to have this deployed in a Zcash wallet, hopefully, but yeah, it's just, we're just taking the first steps towards that. What else? We have the RFC. It's kind of done. We're just waiting for the IETF process to finish. And I think, yeah, that's it. I see some questions in the HackMD about if all code was reviewed or only Ristretto. We reviewed, the auditors reviewed all the cipher suites, but the implementation of the elliptic curve themselves was out of scope, except add 448, which, since there was a crate that we use a crate that wasn't super well known, we also asked them to audit it. But yeah, they audited all surface suites, just with the exception of the elliptic curve code.
Yeah, we'll talk a little bit more about those questions in a few minutes.
Okay.
And obviously, your current plan is to use it with the Zcash wallet, and you're supporting the ITF effort. ITF is not doing SecP and Zcash, and you're offering both. So any particular comments on the status of the differences between those? Are they parallel, one's behind the other?
Yeah, that's a good point. We're following the RFC exactly, right? We just provide the services that are in the RFC. So one important thing is that the RFC has a SEC 256 PK1 cipher suite, but that's not compatible with the taproot signatures from Bitcoin. So yeah, we only provide this non-compatible cipher suite, but it could kind of easily be adapted to work with taproot. Yes.
Thank you. Very useful. Don't know what the right name is for the Square Frost SecP 256K1 Blockstream, etc. repo. As far as what the team would call it, who wants to represent the status on that one?
I can take that.
Thanks.
So yeah, it's not affiliated with Square or Block. You know, we'll probably use it in the BitKey. I'm on the BitKey team at Block, and we're definitely eager to use Frost for our product, but it's not. There's no IP associated with Block. There's no funding associated with Block. So I'd call it the SecP -ZKP Frost, I think, is maybe the best name for it. And in terms of the current status, I've got a PR that I've been working on that is getting into a fairly mature state. And the current plan is to split out the signing code into a separate PR, because that's pretty much ready to go. So we can kind of get that merged and just kind of assume like a trusted setup, or you got your Premier shares from some other way. And then Tim Ruffing and Jonas Nick are actively working also with Lloyd Fournier on working on and I'm helping with this as well, working on a Frost BIP, and specifically getting down the spec for how we want to do the DKG, which has gone through several iterations. And once that finalizes, I will be updating the DKG portion of the code. And the goal is to get all of this merged by the end of the year. And the BIP will be a standardization effort in terms of how we can implement Frost in the Bitcoin world.
Great, thank you. So anybody else have another code base that they're working on, or going to be want to talk about the status? You can raise your hand or just speak if you like. I know there's several others out there. I just don't know how many of them are active and progressing. So no reports on those right now. Okay. So I have a number of different questions on distributed key generation. It's evident from the discussion that this is one of the most difficult parts. that there are multiple approaches which may or may not be compatible. And then there are new approaches like Storm, etc., that are, in discussion. I will also add to that the several people have talked about rekeying and other different types of things that might be possible with distributed key generation. So let's not limit this discussion to just the questions here. But in particular, I at least wanted to get these done. So starting off with, does anybody have any comments about some of the drawbacks of their current DKG, or concerns or advantages that others might not be aware of in your implementation of DKG?
So in the work that Jesse just mentioned, where we're looking into variants of DKGs, together with Jonas Nick and Lloyd Fournier, I think this is pretty much a work in progress, and but I think people haven't really heard about it. So our goal there is to come up with a rather simple DKG. So we drop a robustness requirement. That's a bit in the spirit of Frost, where when you start to drop robustness, everything becomes a bit simpler. So we did the same, and but we want to have a DKG with kind of, as I wrote in the document, with batteries included. It means that there is a broadcast channel included, in the sense that there is a explicit check in the end that everyone agrees. Of course, we can't have robustness here without any further setup assumptions, but we can at least have the guarantee that if everyone agrees, then we know that everyone has agreed. So we may not terminate, but if we terminate, we know we're safe. It also includes secure channels, and it includes backup facilities and so on. So this is supposed to be something that engineers can pick up, implement, and hopefully they're safe without caring about all these setup assumptions. But we don't have any advanced features such as, let's say, robustness or things that are mentioned on the slide here, Chrome rotation, or use the shares for other protocols. This really builds on simple PadPop, which is the DKG, the Peterson POP variant that we used in the Olaf paper, which is really only to be proven secure with, or which is only proven secure together with Frost. So it's really coupled to Frost at the moment.
Thank you. Does the Zcash team have any questions for him on the ZKP DKG?
Yeah, I think we might have discussed this, but we also have an implementation of DKG, but our crates, they don't handle communication, right? They just provide the functions that people need to run DKG, but all handling of communication needs to be done by the caller, and that's a tricky part, right? You need encrypted, authenticated, and also broadcast channel to do DKG. So yeah, just curious on how people are implementing this in practice, like really the communication part.
Yeah, what secure channel are you using?
Yeah,
what is it based on?
So
Yeah, exactly.
in ours it's really, I mean, at the moment we're just drafting a specification, but the idea is that we just draft the algorithms, but the algorithms include a secure channel construction, which is super simple. It's like you exchange keys in the beginning, and then I mean, the only thing you need to send encrypted is this one share. So it's not that we set up a full encrypted channel. We set up a ECDH shared secret, but we just use it to encrypt one message. So it's basically authenticated public key encryption. But because it's one message, it's much simpler than having a full secure channel where you need to care about message ordering and and other stateful stuff and replay attacks and so on.
Right. So basically, you have used public key encryption to authenticate the participants. So you just assume that everyone else public keys.
Yeah, I mean, we have to make some assumption, yeah, and this is one way you can do it in our protocol. We also have a simplified version of this but it's just more like a convenience swapper where you basically hash all the public keys and then you have a short string that you can compare with everyone,
Okay.
which is probably a bit more what people would do in practice. On the other hand, if you couldn't use this, so like say I checked your public key in out of band, but I couldn't use this then for another setup because the hash of the shared string would change. So it's a bit of a trade-off if you want to compare individual public keys, but that's more annoying for users and implementers, I think, and they wouldn't necessarily understand.
Yeah, I want to jump in with a question. So if you have a broadcast channel, you shouldn't have to do another round at the end where you compare keys, right? Because if everyone sends the same commitments, then they all should be able to derive the same keys at the end.
Yeah.
So.
Is this the question? Or?
Right, but so it's like,
okay.
So.
Yeah.
Oh, so I guess like, yes, I mean, there's different ways of going about it, but
yeah.
So if you assume that there's this underlying broadcast channel in the first round, everyone sends commitments. Everyone should be able to get the same consistent commitment, and then they should all be able to derive the same keys afterwards because you're consistent. So
so is the question, why is he doing the confirmation at the end?
Yeah, like it doesn't seem like you need to do that.
Yeah, you're right. I mean, when I said broadcast channel, maybe this was misleading. It's more like a synchronization step. So we basically, so what we assume as a setup is that everyone has checked this, has checked public keys with each other, or has compared this setup string.
Oh, so
that means that we all agree on the public keys of everyone, and then we just go ahead and run the protocol without any special channel, and then in the end we use the public keys that are our trust anchors to compare that we actually saw the same thing. So we run the protocol optimistically over a plain channel in a sense, and then in the end we use we use the fact that we have checked public keys before the protocol to establish that we all agree on what we have received.
Okay, let's we're going to talk a little bit more about trusted channels later. Maybe we've already talked about it enough. But I wanted to maybe do the other way around. Conrado, would you want to share a little bit about the status of your distributed key generation and these questions or related questions, and then we'll let the ZKP team ask you questions.
Sure. Yeah, like I mentioned, we have an implementation of DKG, but it doesn't handle communication, so it's kind of very straightforward. Only now we are starting to implement some mechanisms for communication, so I don't have much to share about this right now. And about the question, yeah. I think something important to mention, I think, in the context of Zcash or other cryptocurrencies, I think this is what people want, right? DKG, they don't want trusted dealer key generation, they want DKG. So I think it's really important that we actually provide this to people, because it's probably what they want. But yeah, this is all I have.
Okay. I'm gonna jump in as well.
Please.
So yeah, so just to kind of clarify, there's by DKG there's several different protocols. So the Zcash implementation implements the DKG as specified in the Frost paper. Tim and Jesse and others are sort of working on 2 round, or I don't know how many rounds, but kind of like variants thereof. And Tim, correct me if I'm wrong, but the proof kind of still assumes frost under the hood. So I think, there's these DKGs which are proven with respect to frost or variants of frost. There's then the question of like DKGs that can be used in any setting. These 2-round DKGs are not proven secure generally. So the DKG that Ian mentioned, Storm, that him and I and Douglas Deblo worked on, is basically a DKG that can be a drop-in to any setting that needs discrete log keys. So the reason why we did that is because we had a bunch of questions around using PEDPOP for other things, like you said, for example, for like threshold encryption. And right now there's not a proof that Pedersen is secure in that setting. And basically you need like separate proofs for all of those settings. So that's why we have Storm, where it's basically where you assume discrete log keys, you can use Storm and the proof just sort of holds. So I think it's kind of important to separate out these types of things and more generally just know that, like which DKG you use for which setting is important. And if you want kind of a generic DKG that can be used in any context, then you have to pick which DKG. You have to pick that one carefully, basically.
Right. That's exactly what I wanted to know a little bit more about. So I'm going to move to the next one. So I was particularly pleased to see that the Zcash project was offering trusted dealer generation in their code base, partly because I feel like this is a transitional form. Blockchain Commons has been using a Shamir-based with some extensions to support 2 layers in one of our wallet specifications. And we've really been wanting to move to VSS. And if we're going to move to VSS, why not move to one that's compatible with Frost? So this was kind of like, am I going to be, staffing up to do something here? So Zcash did implement trusted dealer generation. It does not sound like the ZKP team has done. I'd be interested if someone who's been working on that on the Zcash side could talk about why they implemented it. Just some other sort of related things. Part of the reason why I was interested in trusted dealer generation is we also have a similar type of thing to this for open silicon vendors called Silicon Salon. Where we've been talking about generation of self-sovereign keys, better security on the hardware. And so we feel like the trusted dealer generation might be useful in that particular category. And then just in general, especially if the cryptographers among you, are there risks of transitioning some of the Shamir protocols to leverage the VSS that results in trusted dealer, or am I misunderstanding something? So anyone want to speak to that on the Zcash side?
Yeah, I think the main reason we did trusted dealer is just because it's much simpler. Don't have many rounds of communication, just generate, split it, and provide each share for each participant. I have the impression that in practice, like I mentioned, people will want DKG because they don't want the keys to be present in memory at any point in time. But it still might be useful, like in some specific scenarios. Maybe you can generate run trusted dealer in an offline computer or maybe even a hardware device, and then you would still keep security. You would still minimize the chance of compromise. But yeah, that's all I have about this.
Okay. Anyone else have comments?
I think my take on trusted dealer trusted dealer generation is that it's not really worth the effort. I mean, if you're going to add so much complexity because you add a threshold scheme, then I think DKG really makes sense. On the other hand, now we just discussed this with the Jesse, or as Jesse actually mentioned earlier, our plan for implementation is now to split the current pull request and move forward with signing, where we can think more about DKG, and this then actually needs some trusted dealer or trusted key generation, because otherwise you couldn't use this signing code. And I think as a as just a tool to get this out in the world and to let people experiment with it, and also to maybe add test vectors that work for just the signing protocol, I think that's useful. But in practice, it's always hard to consider all use cases, but I don't think it's a very useful use case to have a trusted dealer.
I know for me, I'm also co-author of the DID standard in the W3C, but I've been very frustrated with sort of the single key architecture that has evolved as that standard moved on. And I'm looking forward to it just to help that community consider the possibilities of what's possible with multisig and quorums. But I don't think they're prepared to even begin to think about DKGs. So this just for me allows for better demos, better proof of concepts. It also becomes kind of a constriction point where we can basically say, hey, we're going to standardize on some specific objects and tests and data formats that in this everything before signing is clearly separated from using these to sign. So that's my interest in it. Any other comments on this one?
Yeah, I think trusted dealers could be useful for some custodians. For example, when I was at Coinbase, we had something like this because we already had a secure, trusted process for generating Shamir shares. But then we could use threshold signing to sign with the shares without having to have a trusted reconstruction process to bring the shares back together. So for certain custodial use cases, I think it can actually be quite useful.
Yeah, we're part of what SSKR is used for with the Blockchain Commons Gordian standards is for improving self-custody. So the ability to do VSS and be able to have the shareholder sign different types of things without necessarily restoring is just really useful for wallet resilience of legacy keys, personal data, etc. Which sort of leads us to resilience and trust. So I don't think we've well defined. I mean, we kind of have begun to understand the secrecy requirements of private keys. Obviously we'd love to have single keys, somewhere deep in the silicon where it can never ever be seen, and can't has multiple layers of physical and other resistance and etc. And we never quite achieve that. I mean, we still have a lot of keys in browsers and things of that nature that are insufficiently timing attacked, but at least we know the level of care that's required for a single a private key that is a single intended for single sigs. But I don't think we have a good understanding for the privacy and care that is needed for a generated share. So, I mean, there's some simple things like reliability issues and does somebody have it a year later and et cetera. But then there's also these concerns of correlation or DOS attacks or other things, and also kind of reuse of the initial keys, the keys that are used to generate the shares. I mean, in theory, I believe they can be thrown away, but is there some utility to keeping those around? Which leads to what are the real requirements for trust in the wallets, and what changes to trust models for wallets are needed given the opportunities of a DKG. And then sort of related to the other event I host, are there opportunities to increase trust by implementing parts of Frost in Silicon? Anybody want to, kick off any thoughts on related to your projects or, the future of Frost in this area? Yeah, I think I've asked this question a couple times before. Go ahead.
Yeah, I don't have much to share exactly about this, but something related is we're wondering in the context of the cash or other cryptocurrencies, people are used it to, they write down the seed phrase and that's it. If they lose, if they PC or phone stops working, they can restart from the seed phrase and they're good. In the case of Frost, it's a bit trickier because on one side it's trickier because you don't need just a share. You need the share and the group key and the identifier, and maybe the other people's identifiers. So it's more information that you need to back up or save. On the other hand, of course, if you lose your key, you can still, depending on the threshold, you can still sign. And particularly something that we also added in your crates is the ability to repair people share, right? You can, if you have a threshold of people come together, they can restore another person's share. There's a protocol for that. So maybe we don't need to care that much about people losing shares. But I think what the slide is asking is more about the safety aspects. Yeah, I'm not sure. It would be good to have something like, for example, a hardware wallet that can do Frost, can do this, you generate a signature share using Frost. That would be great.
Yeah. Well, there's definitely discussion. If you go to siliconsalon.info, there is discussion by Silicon designers about supporting this type of thing at kind of different levels, and they're really unclear on which ones are appropriate. But it's everything from one of the vendors actually has 3 different CPUs on the same chip. So one's an ARM, one is a RISC, and another one is an FPU. And they're like going, well, can we do kind of Frost internally so that no single chip CPU has the whole secret? Can we do DKG down at that level? But then there's also discussions of, okay, so can we have a private trusted channel between 2 identical chips, such that neither of the chips individually have to be trusted, et cetera. So there's some discussions in that in siliconsalon.info. So, but clearly this is something we'd like to, in particular, Blockchain Commons would like to try to move forward some better, more clear answers to these questions in the future.
So one related thing is that that was an idea that came up in the Bitcoin community is how could you let's say you have a payment channel over the Lightning network, and you, as your side of the payment channel, you want to use Frost for your node because this makes key storage for you much more secure. And it turns out, so we looked into this a bit, and it turns out it's much harder than just Frost. And I could imagine that the use case you mentioned is similar, because in these applications it's not just about usually not just about the cryptography in the sense that you need a secure threshold signing scheme, but you also need to agree on the state. So
Yep.
In the Lightning channel, yeah, there's some state, and you need to do the state management. So it's more like a state machine replication or consensus or BFT or whatever you want to call it, which is another hard problem. Of course, there are also solutions for that, but then Frost is only really part of the answer.
Thank you.
Also, I want to add I think it would be great to have hardware wallet support or, secure enclave support. But I think one thing to really pay attention to there is, since we can't use deterministic nonces, or maybe we could with like some zero knowledge proofs, but assuming we're not doing that, there's like more inputs coming into the silicon with regard to the signature and the nonce components. And so you have to be really careful that you can't trick the hardware wallet into reusing a nonce. And especially if you don't want to have to make it depending on some kind of state or counter or something like that. So that's something I think just to pay very close attention to.
Great, thank you. Okay, moving on to curves. So this, the Zcash team has implemented in the Ristretto family, which is, a subset of the ED 25519, well, 25519 in general curve. But they've also done the SecP implementation, whereas the ZKP team is only doing SecP. So this, wanted to discuss the opportunity, challenges and opportunities here. There's a lot of ED 25519 infrastructure out there. I know Blockchain Commons has been kind of frustrated with the lack of some clarity, even within the IEATF standard for 25519 and the implementations and stuff. And then obviously there's the whole reason why we're moving to Ristretto. So I just don't understand. So this is more the question for the Zcash team. What are the limitations of leveraging existing 25519 infrastructure, or do we need to be completely moving to Ristretto, or is it, it's not a big deal, you just convert the keys to Ristretto and do them in there and then move them back? Any thoughts there? Chelsea, I know you've had some interesting discussions about 25519 in some of your talks.
I don't actually know if I talked about 25519. That's surprising, but I guess Conrad can talk about this more, but the IETF draft covers a range of curves. But yeah, Conrad, you should jump in.
Sure. Yeah, to be clear, we have 5 cipher suites. One of them is at 25519, so you can use Frost and generate a signature that can be verified by any at 25519 verifier, and it will work. And we have another cipher suite, which is Ristretto 255. So you can use one or both, depending. If you need compatibility with Edge 5519, you can just use that cipher suite and you're done. It's a bit less efficient than Ristretto because Frost needs a prime order group and Edge 5519 is not prime order. So that basically entails that inside the Frost implementation, when you receive a public key, you need to validate if the point is actually is inside the prime order group, which is a bit less efficient, but it works, right? The signatures that are generated by this process are compatible with 25519 verifiers. I never thought about the possibility of converting between keys. Doesn't sound like a good idea, but no. Yeah, maybe it works. I will need to think about it.
Yeah, Deidre in her podcast was talking last month about, hey, if we can find out that the P variant is actually safe, should we all move back to P? Yeah. And it was kind of like, because a lot of the speed ups that 25519 offers can now be implemented by various tricks to convert things in a fashion so that you get the speed up of 25519, but the standard for the P curve. So I don't know. I part of me just wants to just move completely to Ristretto, but I just don't know what what other people are just prime order curves. And if anybody has any thoughts on that. So I have doubts about this, but can is there the distributed key generation phase completely different for the different suites? Or can the result of a distributed key generation be then used for signing with Ristretto and for SecP? I didn't understand that.
Yeah, if you compare Ristretto and SecP, I don't think they are any compatible because it are different groups, right? So different elliptical groups with different orders. So I don't see how you could do a single DKG for both. But if you talk about Ristretto and Edge 5519, they're kind of related. So maybe there's some way to make it work, but I would need to also think about it. I don't know.
Yeah, maybe my question isn't well phrased. I think there's obviously we have this distributed key generation phase, which results in a share that can then be used for for the signing. So I guess the question is, are those shares completely different in format because of the curves they use, such that they're basically, if you want to do both, you're going to have to do it. You're going to have to do a distributed key generation separately for each. If you want to later sign, or is there some way that the result of the distributed key generation can be used for signing either with Ristretto or SecP?
The key generations are strongly tied to the group order.
Okay.
Yes.
So,
Yeah.
So as was just said, Ristretto and SecP, no. Ristretto and ED25519, almost certainly yes. And if you're talking about two curves that are basically equivalent, but one is in Edwards form and one's in Montgomery form or something like that, then yes.
Okay.
But mostly no.
Okay. Thank you. We've had some discussion on trusted channels. So we've already talked about the distributed key generation requires a trusted channel, and a little bit on the progress and requirements for this. But I also wanted to talk about the signing. So signing doesn't require trusted channels, but there are obviously privacy correlation issues if signed over untrusted channels. Anybody doing anything here? I guess I'd maybe push this to the ZKP team, or once you do your generation, are you reusing any of the Diffie-Hellman that you used in previous parts of the DKG? What's any thoughts here?
I think that's at least not something we are currently considering for the spec. I think like this really depends on the application or on the caller. So I mean, if your application, if your system anyway wants to have secure channels for privacy reasons, which is an obvious one, for example, then I guess you would use them for you would run DKG over the secure channel. You would also run signing over the secure channel. The reason we are including secure channels in the DKG is really that we wanted to have something with batteries included, where the caller or the user can't screw up. Or well, I mean, I guess there are 1,000 other ways you can screw up, but at least we remove that one. And yeah, but there, I mean, it's pretty cheap. What we do there, it's just one ECDH, and we use it for encrypting one message. So even if you already have a secure channel, I think you could just go ahead with our DKG and yeah, accept the minimal overhead there.
Okay. Any more thoughts on that one from anybody?
Yeah, on our side, specific case of Zcash, you're using Frost to sign a transaction. The transaction details are private, so we need to encrypt the channels, so authenticate channels. So yeah, we can kind of get away from that. We don't have any specific mechanism in mind for that still. It's just a random comment about the last item about identifiers. Something that we added to our crates is a function to do like derive identifier from an arbitrary string. It just runs like hash to group with a specific domain separator. So maybe that's something just talking about this. So maybe this is something that is useful to other people, and you can take a look at our repo. And if you like to use the same domain separator, that would be, I think that would be good for interoperability.
Yeah, I would love to see that maybe detailed out as something we can share.
Sure.
It's sort of related. It's sort of we get to the next question. It's sort of there is both alligator transformations for SecP and for 25. I don't know if there is for 25519. I know there is for Ristretto, but like should we be integrating that future of being able to have various keys be represented by random, unidentifiable from randomness, or is it just a completely separate layer? We don't worry about it here. Are there other anti-correlation things? And then Jesse put in the notes that the ZKP version is using the X-only pub keys and the BIP340 schnorr, whereas the ZKP team has been, I guess, using different public key and isn't necessarily compatible with 340 schnorr. And what are the, do we want to try to have more compatibility there? Do we want, especially since the ZKP team is trying to push some things through IETF, which has not yet accepted a K1 curve in any of their things that I know of. Do we want to be, is there interest in your team in having compatibility with X-only pub keys and 340 schnorr? So what kind of other alignment with crypto and other libraries and things like identifiers and et cetera, are needed or, people are interested in? Conrado, you spoke earlier that it sounded like you were not doing BIP340 schnorr, but there was some interest. I mean, what help do you need, or what kind of how can we coordinate this better? What are you looking for?
Yes, we are focusing, because the Zcash Foundation, we're focusing most on Zcash, of course, so we don't have the bandwidth to work with Taproot, with Bitcoin. But of course, this is like probably the hugest application of Frost that is kind of obvious. So yeah, we would love to see this implemented. I think we need two things: implementation, it's, of course, but also some kind of specification. I don't know how exactly that works in the Bitcoin world, if you need to write a BIP or something. So yeah, it's something that we're interested in. We can help with if possible, but we're not we're not planning to do anything concrete to address this right now.
Okay. Well, this is something that Blockchain Commons is definitely interested on, at least the specification side, maybe some test vectors and things of that nature, because we do work both. Well, we work with W3C, IETF, and we also are involved with the Bitcoin ecosystem. So, there may be something that we can do to kind of kick things off. We kind of consider ourselves in the mode of incubating specifications, taking them up to a particular level, and then moving those specs as appropriate to IETF, which we did recently with deterministic CBOR and or in the case of like Bitcoin, we're doing some things with QR codes and other stuff. So we're definitely interested. Any other alignment with other kinds of crypto that people would like to bring up here? Maybe Ian or Chelsea? Okay.
I mean, just to
Go ahead.
comment on what Conrado said, yeah, I think that totally makes sense. I think it's similar for us. We're happy to talk and look into stuff, but we probably won't spend our time on too much on other ecosystems. It's a bit a shame that we with WIP 340 we introduced X-only keys. I mean, of course they're shorter on the blockchain. That's important, but it's kind of put a distance between us and the rest of the world a bit in a sense. Whereas I think if you ignore X-only keys and of course they're only a detail, but if you ignore that detail, then the main difference between what the teams do here is probably the curve, but this is not a big difference in terms of ideas and specifications. I think you could look at our spec and just plug in another curve, and I guess the same is true for the RFC draft or the IETF draft or any other implementation or specification of Frost.
Okay. Well, definitely will be on the agenda for Blockchain Commons this year, because I think this is important. Performance, I suspect, all of you are using like the latest computers and such, and maybe haven't even looked at performance issues. We do have people that want to do Frost on potentially very low power devices. We've already determined, for instance, like one of the silicon devices that one of the designers wanted to do, they want to be able to do it under near field communications power, which is very low power, and they've determined they can't do it right now because there just isn't a silicon accelerator for their particular thing. Has anybody looked at performance issues, minimal processor requirements? Let's see if anybody's been puzzling with this.
We haven't examined this closely, but we did have some. There is it's not super novel, but there's implementation improvement that you can do. The aggregate step of Frost requires a multiscalar point multiplication, and that's the part that takes most time in the entire protocol. So we have, I don't know, we have 100 participants, so we need to do 100 point multiplications and sum them. But you can do, there's particular algorithms for speeding up this type of multiscalar point multiplication. So if you use that, it improves a lot, like depending on the amount of signers, even like 80%, something like that. So this is the important thing to be aware of. We have a blog post about this in your site. And low power devices should work, right? Because the bottleneck of the protocol is elliptic curve multiplication, and this is something that has been optimized a lot. Depends on the curve, of course, but curve like Ristretto and H25519 have been optimized a lot. So yeah, it shouldn't be too hard.
Okay.
Is the interest in doing the combining of the signature shares on a low power device, or just doing this individual signing on a low power device?
Well, I think both, and not necessarily at this, by the same class of devices or whatever, but there's definitely interest in the sense of, say in the digital identity field where you have very important issuer keys, which require, special care, and they're currently, the bigger single key parties are doing all different kinds of custodial and Shamir backups and things of that nature. Wouldn't it be wonderful if they didn't have to do all of that and could basically, have devices that, were able to handle that in a fashion, including things like, rekeying quorums and things of that nature. So I'm not sure. I do know that that's one of the obstacles that they're basically saying why they don't want to move to multisig.
The reconstruction is an entirely public operation, right? The shares aren't even secrets.
No, that's true.
So you can use a low power device to generate the shares, and then anyone on any computer anywhere can combine them into the final signature. There's no reason that has to be done on any particular device.
That makes sense.
Right? So only the actual signature computation, of which the most expensive part is the multi-exp to compute the group commitment. If you're using Frost 1. If you're using Frost 2, that's cheaper.
Okay. Anyhow, that's again something that I wanted the community to be aware of, that there is interest there. We don't have any of the hardware vendors with us today, but there's definitely been some discussion about that question. Okay, so there obviously is a roadmap going on in the IETF. Currently, as I understand it, it's an IACR with the target of becoming an informational draft, not an actual standard. But maybe I don't understand that, what your roadmap is in the IETF. I also heard at the beginning of the call, there were some things proposing this for NIST quorums. I think I was vaguely aware of the call with the NIST, and I just assumed it was another quantum one, that and not something that Frost would be suitable with quorum. So I must have misunderstood that. Any other things going on in international standards?
Yeah, I'll jump in and I'll speak to both of those. So for the IETF, it is just an informational draft. That's fine. If there's interest in standardizing it within the IETF or something, that will have to be a separate effort, and I will not be involved with it. But I think the main goal for that draft was to get out something that everyone could sort of implement, something that's close to parity. And then, we have a team right now and we're submitting it. Their NIST is doing a call for threshold schemes, both quantum, post-quantum, and classical security, and Frost will be a submission to that.
Okay. And I would love at some point a URL to be able to participate in that. So, in your, reviewing your proposals or whatever. So let me know as that progresses. Anybody else doing anything? I mean, obviously we've also talked BIP. It's not an international standard. But, we've also heard about moving some things forward in the BIP efforts. Any other kind of shared specifications, collaborative standards going on? I know that as some of these intermediary formats, things like the identifiers that Conrado was talking about earlier, the various share formats, etc. We would be interested in what was necessary to be able to have binary representations of them. in CBOR for variety of reasons, including ability to back things up and stuff with various standards. So if people are interested in that, that's something Blockchain Commons would like to do once these kind of get closer to final, or at least usable for testing.
Yeah, there's something I like to add about this. The RFC doesn't provide any data format. I think it used to have in one of the first submissions, but it was decided it was out of scope. But our Create implementation or Rust implementation does have a binary format for encoding the structs. We provide surge, so you can use anything, but we choose one particular encoding as the default encoding for our Create. We choose postcard, which is a very simple binary encoding format. I hadn't considered CBAR, but I'll look into it. Seems interesting. But yeah, I'm interested in if people have opinions about how we should encode things. We welcome these opinions because we would like to have a default serialization format, and it would be good to make it standard. Not sure how we make it standard, like if you do a IETF draft or just some document, whatever, but it would be good to have a standard.
Well, Blockchain Commons has been doing this a lot this year, and we've learned some of the challenges. Wolf can speak to that, but we've had some success, and in particular, deterministic CBOR, which is a subset of CBOR that addresses some of the cryptographic problems that so that you can have a single signable CBOR object that is consistent no matter who constructs it, is this moving forward toward a track to become an RFC, and we have Rust code for all of that. We have actually more than we have Rust and Swift and TypeScript and a couple of others for DCBOR, and then we also have this envelope format that depends on that. So we are very interested in this, and we think there's some advantages to the CBOR format, and we also have succeeded in dealing with some of the snafus of the IETF, IANA challenges of getting these things registered. So I think we could help everybody avoid that on these. So we're very interested. I mean, for that matter, I'm very interested, not just for Frost things, but I'd like to see X only be a ITF CBOR format. So that'll solve some problems. Any comments on data formats or international standards? Okay, so moving on to we're getting close to the end. Any wildcard uses of Frost to the community you think the community should be considering? Like you go, well, we can't do that, but we'd love somebody to do it. Or some edge cases. I mean, obviously Storm is separate because it's useful for other things, but could be other things like Storm or other ways to leverage the cryptography of Frost.
So Tim kind of alluded to this earlier about using Frost with Lightning, and there's issues around like getting consensus around state channels, but there's an interesting cryptographic piece of this that I don't think has been fully explored, which is the notion of nesting Frost. So for example, if you have a MUSIG construction like in Lightning with a 2 of 2 MUSIG for Lightning channel, to what extent can you nest Frost inside of one or two of the MUSIG keys? So 1 or 2 of the MUSIG keys would have been the output of a Frost EKG, or could you nest Frost in a Yeah, that can also be useful, for example, for let's say a custodian has wants to have a quorum of humans and a quorum of servers that both participate to create a signature. You could have a MUSIG 2 of 2 at the top level, and each of those would be a Frost T of N for the component keys. And we don't really have any security proofs for that, but there could be kind of interesting use cases there. Another thing is using like a BIP32 style key tree hierarchy with Frost, which definitely works, but I don't think we have like security proven for how for that specifically. So those are some kind of interesting interactions with Frost that I've come across.
Thank you. So that kind of is a good segue to the next slide. I believe some of you were involved in Roast. Any progress on that? I don't completely understand how much of it's an extension to Frost as opposed to a pretty major change.
I think the design goal was that it's really just an extension, and there's no progress, I think, but there's also, I think there's no one currently working on it. So I think from our side, it's basically there. I'm not sure if it would make sense to write a standard for it. The nice thing about Roast is that it's a simple wrapper of Frost, so you can't really get it too wrong in a sense. So you like if you, I think even if you implement it just looking at the paper and without looking at any specification, that's probably will be a safe implementation. I'm not sure if people want to
So is
want
it
to
like
use
there's
it.
a rare version, then there's the medium rare version, then there's the fully roasted version?
Yeah, in a sense. Yeah. No, I mean it's supposed to provide robustness, so you're guaranteed to get a signature. And of course, if you implement it wrongly, then it won't work and you won't get a signature in the end. But this is something that could be, or that would easily be catched probably when testing. But as long as you just use Frost in a black box way, whatever you do with it, you can't break, you can't screw up with unforgeability. And because Roast just uses Frost in a black box way, yeah, Frost should stay unforgeable, so nothing can go wrong there.
Thank you. Yeah, I'm interested in Roast just simply because as you talk about larger quorums, which isn't typical, say, for the cryptocurrency world of Zcash or Bitcoin, we do want to be able to have, maybe a quorum signature for all the stockholders of a company to approve, changes to articles of incorporation. In that case, you might have thousands. And you don't want to be able to have parties that are smaller than the quorum being able to deny or cause problems for the quorum to legitimately be able to sign. So that was what I like about about Roast. Oh, I hadn't thought about that. Fedimint can also have large quorums. Yeah, Jesse, weren't you talking about some point about moving Fedimint to use Frost rather than the current multisig or something? There was something. I thought it was you who mentioned that.
There's some folks working on that. I haven't been involved, but I think there was like some kind of Frosty Mint exploration and
Frosty Mint. I love it.
something along those lines. I think there are people interested in that use case, but I haven't worked on it specifically.
Great, thank you. So what other proofs can a Frost quorum do? We talked earlier that there are some risks for using it for things that maybe Storm would be able to address. but I'm just thinking more broadly. I know that when I brought Frost Schnorr forward to the digital identity community, they said, yeah, there's some value for what I think I've heard called non-accountable signatures. I think that's a Greg Maxwell, Peter Woolley term. I'm not sure if it's a more broad term, but basically a non-accountable signatures, you don't know who signed, but it is, the quorum has provably signed it. But they say there's just too many cases where they really need to know who signed it. For instance, the board of directors, or somebody who is accountable to their decision. And I didn't know if there was any kind of variant or tricks or whatever that members of a Frost quorum could also do an accountable signature.
It just publish the signature shares.
But if
you can just publish the dead eyes, right? That's enough.
Okay.
Each signature share is independently verifiable against. People would have to know the participants' individual public keys, but that's unavoidable if you want accountability like this. If you want individuals to have identities that can be accountable, they have to have public keys people know.
Well, does that still mean, I mean, are these just, just multiple single SIGs, or is this an aggregated Schnorr at the end?
So you get the aggregated Schnorr at the end that verifies with your standard verification. But in addition, if you care about who contributed to it, you look at the individual signature shares. I mean, it's linear size and the number of signers, but that seems hard to get around. If you want to end up with a list of signers, Chelsea, maybe you actually have, like, you had that paper on this similar topic.
Yeah, that's a little it's a little different because it also tries to preserve privacy of who signed. I think if you just care about accountability, I don't see why you couldn't, like, yeah, if you want a threshold T out of N, but you want to also know which T signed, the easiest thing to do would be you publish your Frost signature, and then you have some ledger or something where you persist information. I think BitGo does this, I'm pretty sure, because they have threshold signatures, but they also say they have an accountability layer. So yeah, so you just do Frost, you publish that, and then you could either persist the T individual signature shares, or we have this nice multi-signature scheme called Musig. So you can also aggregate them if you don't want T-sized storage, and then you just need the public keys. So I think there's lots of ways around this.
So it'd be a T of T for the accountable.
You could only get away with that. I can't see how you get away with that without having a combinatorially large number of Musig public keys, like one for each size T possible quorum.
Correct.
Yeah, and this is something you could do, but yeah, you can build a Merkle tree or whatever. But yeah, but I think it really depends on the setting here. I mean, or on the verifier. So let's say this is for UTXO on the Bitcoin or on the Zcash blockchain. If you have T malicious signers, they can just reconstruct the key and sign, and there's no accountability for this. So then the money is gone, but you don't have records. So it really depends on whether you know that you have these records so somewhere else, so the partial signatures. So of course, if you did the signature, you can prove to others that you did the signature, but you,
yeah,
I'm not sure if how useful that is.
Chelsea, you said there was something that had greater privacy that you were working on as well, or some variant in this family.
Yeah, I mean, I had a paper a little while ago on private and accountable threshold signatures, but it's more complicated. So I mean, it's there, but I think regardless, you're not really going to be able to get around needing some kind of second persistence layer. That's probably always, you're always going to need something like that. So.
Okay.
I think if you want sorry, I don't know who was just speaking before that. Was it Tim?
Yeah,
Yeah.
it was me. Yeah.
Yeah, I don't, for some reason, Zoom's not showing me who's speaking. So, yeah, if you want it to be the case that you can tell who signed even without their cooperation, you're basically just doing a T of N, like just T signatures.
Right.
Right.
That
And
works.
then
Yeah,
you just check that you have T individual signatures and you're done. But then you don't get a single signature that is also independently checkable.
And
Like,
anyway, this scheme is pretty much underrated, right? It's not compact, but it has everything else. It has accountability. It's non-interactive. It's easy to set up keys.
No, it's a great
yeah.
Except for the linear size of signatures.
Yeah.
It's a perfectly reasonable scheme for T not ridiculously large.
Okay. Yeah, and I definitely have some interesting thoughts, regarding, different tricks of using Musig 2 with Frost or Frost with Musig 2 that Jesse was talking about earlier. But is there any other kind of related cryptographic opportunities that we're not thinking about? Obviously, Schnorr has a lot of variants. There's, the old blinded Schnorr, other, adapter signatures in Schnorr, etc. Any thoughts about any of these other variants of Schnorr with Frost?
Yeah, so I actually have in the test suite for my Frost implementation, using adapter signatures to do multi-hop locks, kind of like PTLCs, where it is, I think mostly useful if we were nesting Frost inside of Musig, but you can definitely do adapter signatures with Frost to create these multi-hop locks, which is interesting. I also wonder if you could have like, almost certainly you could also use like a Musig DN style zero knowledge proof to get deterministic nonces for Frost is, I think, another thing we could do.
That's interesting.
Anybody
go ahead.
Putting Frost inside of Musig, that would require you to use the trusted dealer variant, like way to distribute the Frost keys. The other way around. But
correct.
If you had like a Frost inside of Frost or something, rather, then you would have to use the trusted dealer at least on the inner Frost. Because
but not for go ahead.
Yeah, not for music. Each subgroup of Frost, if you used a DKG, would produce an independent random key, and so the outer layer would have to be one that supported independent random keys.
Thank you.
I also want to make sure people are aware of the.
Not sure.
No.
I mean, I haven't written down the scheme, but I could imagine it works. I think you claimed in an email 5 years ago that works. Maybe not 5 years ago.
So okay, so let's talk about it. So you want a Frost inside a Frost.
Let's say Frost inside a Frost. Yeah.
Right. So if the inner Frosts all are DKG'd, then they're each going to output an independent random secret key.
Mm-hmm.
But independent random secret keys can't directly be used as shares in a
as
Frost.
Inputs for Frost, yeah. Or for
so you have to do something else there. There are things you can do. So for example, there's this trick that if you of converting between n of n shares and k of n shares that involves a combinatorial blow up, so n and k can't be too big, where in one step you just basically make a shared secret for every size k minus 1 group of the n, and give that value to each of those people, and then everybody just adds up their values and multiplies by some well-chosen Lagrange coefficients, and then magically that turns out to be a Shamir sharing. And I might have gotten a -1 and a +1 mixed up somewhere, whatever. Anyway, there's this trick where you can convert independent random values into Shamir shares. And
Interesting.
And that's useful because if you've set up your Shamir shares that way, you have this super awesome property that you can forward secretify them just by hashing all the original independent random values and then doing the adding them up with the Lagrange coefficients again, and you end up with a new, completely forward secretly independent sharing of a new random value. With no interaction. So the key update is completely non-interactive, like no messages at all. It's all local computation, which is super cool at the expense of something like n choose k plus or minus 1 storage and computation. So if n and k are too ridiculous, that won't work. But if it's not too ridiculous, that's a neat trick that people should be aware of that can be useful in various situations.
Yeah, well, especially
this could be one way to. This could be one way to make it work. Yeah. Now that I remember, I think we had the discussion about nested frost or frost inside frost a while ago, but I think we didn't talk about DKGs. We just talked about signing in there.
That's right. Right.
Yeah,
So you can do it if you use a trusted dealer. So you first you just make up whatever keys for the outer one, then you use that, and
or as you pointed out, if you do frost inside music, that also works, because then
exactly, music
have a
can
public
take
way to make
keys.
Interesting.
Well, thank you very much. It's exactly
there.
That was exactly the kind of discussion that I wanted to say that there's some opportunities here. So thank you. So we're going to wrap up with sort of these kind of open questions. Obviously, we need to convince more developers to use Frost. I know Blockchain Commons wants to help with some of the tooling there because we already have a wallet developer community, 14, 15 wallet developers, different companies. But obviously for them to do it, we have to convince users to use Frost. Any particular tooling that, is not on your immediate roadmap that you would like others to do? There aren't a lot of developers out there who are ready to do some of the cryptographic code, but they could help with other testing frameworks, CLI apps, etc., that would help in deployment. This is something I'm very concerned about. So I want to congratulate the Zcash team for doing code reviews. But how do we collectively do more code reviews? Whether or not maybe our different teams could code review each other's code in some kind of independent fashion. How do we get the different developers and wallet companies, other companies that depend on our code to fund code reviews, I think is an important thing we need to puzzle through. And then specifically for the roadmap of Blockchain Commons in 2024, what other activities can Blockchain Commons do in addition to hosting activities like this? I mean, currently we're hosting a variety of open specifications and references to those open specifications. We're currently moving a number of those specifications into various standards organizations. And we also have a variety of discussion forums and special meetings, et cetera, that we can host. So just kind of want to leave it open. Did you like this meeting? Do you want to do it again? What else can we do? Ideas in next steps. You mind if I just call on the people who remain and see if there are any, just sort of top things in your head? Conrado, what is a next step for this larger community of Frost developers?
Yeah, those are great questions. I unfortunately don't have the answer to most of them. I think the next step is just getting Frost deployed somehow, somewhere, right? We're trying to do that in Zcash by integrated with wallets, but of course everyone's working on their own projects, and I think the next step is getting deployed in whatever form people are working with. To help that happen, I don't know. I think this talk was really useful, at least for me. I think it's good to have run ideas by other people. So we could have something like this, maybe in a couple of months. But yeah, on our side, we just try to get it deployed. The thing that I need more is I would love to have some super obvious way to do communication between applications, right? There are loads of ways to do it, but there's no single obvious ways to do it. So yeah, we're just figuring out this, analyzing multiple options. But yeah, that's not really Frost is a distributed protocol, so you need this, but it's not actually related to Frost. But yeah.
On that last one, I know that we're working now on something called collaborative recovery. And we are hoping to have a server out soon that you can, basically do a trust on first use with that can do various operations for you. That we're, basically, Ledger currently locks you into who your share partners are. We want you to be able to have choice, put it on paper, store it on a server, share it with a friend, etc. Now we're only doing Shamir right now, but the goal is that this is an open standard and could be used for other things besides Shamir shares. So we'll share that with you.
Yeah.
Chelsea, any thoughts here?
Yeah, I think kind of bringing so I think what would be great for Blockchain Commons to sort of keep doing is the outreach to people who are working on Frost. That's very helpful. So I know there's been several kind of, at least I've seen several things floating around about people who've implemented Frost. So that kind of outreach and bringing people together is very helpful. So yeah, thank you.
Welcome. I'm hoping that we can do this again as appropriate in January, February, and maybe with the video of this, we'll get some of the other developers in as well. I think I invited all the ones I could find, but I'm glad you're here. Thank you. Ian.
Sorry, I was just reading Tim's message, and I want to talk more about that. But no, I found this valuable, and yeah, having it again in a couple months, try to get more people out. Sounds good. We're of course moving forward onto the things like Storm, like I talked about, and some other things. Yeah, hope to see good progress in this space.
Thank you.
But
Tim?
I do want to talk about what Tim just posted.
Sure. Why don't we go ahead.
So I'm pretty sure that's not the case. What Tim just posted. Individual signature shares are in fact unforgeable, and in fact that's how you check they're correct, is that they're unforgeable against each individual person's public keys share. Right? So you can check.
Okay, this may depend on the difference between Frost 3 and Frost 2, whereas Music 2 has non-segregation like Frost 3. But for Music 2 at least, we have a write-up of the attack. So if you're a participant of the protocol, you can forge signature shares of other participants. The trick here is that the signature share includes the hash of, or the challenge hash includes the combined nonce, and you can do a rogue key attack or rogue nonce attack on the combined nonce. So like it's not a compilation of a Fiat Shamir style protocol again, because you don't hash your commitment, but you hash the combined commitment. Do you see what I'm saying? So I can, in the first round, I can send nonces for which I don't have the secret key, for which I don't have the secret nonce, but I can create partial signatures. I think I just can't create n partial signatures, of course, because then it would be a forgery.
Because so this doesn't work against Classic or Frost 1, because that's what the individual rows are for, is to prevent that from happening. But if you combine the rows, yes. Okay, I buy that.
This may be true that this is actually really the difference then, or this boils down to the difference.
No, that was exactly the result of the crypto paper, right?
Yeah.
That the exact difference between the security of Frost 1 and Frost 2 is that in Frost 2, a participant can make it look like some other participant signed exactly because of that the individual D's and E's aren't separated because you use a common row.
Yeah, that makes sense.
Yeah, that's right. So for Frost, if you aggregate the rows, then that's true. If you don't aggregate the rows, then the individual shares are unforgeable.
Yeah.
Yep.
So Tim, any next step thoughts? Things you'd like to see?
Yeah, first of all, I agree with what Conrado and Chelsea said. I think it was nice to have this round table, and it would make sense to have it again in a few months. Yeah, I would appreciate this, and I think also the markdown document that we have, we could use this just to add maybe a few more, I don't know, links to stuff we talked about. I think there are a lot of things and ideas we work on, the different groups here, and most of them, at least for the implementation side, are public because they happen on GitHub or another public areas, but we often hear about this stuff only when we talk to each other. So maybe that's an interesting thing to do with a document, or we could have some other channel to exchange things.
Yeah,
I don't know.
We'll be glad to help. Also, like PRs are really impossible to find.
Right. For example, PRs are hard to find. I mean, this TKG repo that or spec repo that Jonas created 2 weeks ago is hard to find because we didn't share with anybody. Of course, it's super work in progress, but I mean, it's public. People can, of course, have a look. Another thing, I mean, Lloyd unfortunately couldn't be here today, I guess, but his project is what came to my mind when I saw the second bullet on your slide. How do we convince users to use Frost? I think because those guys have thoughts on they really have a concrete application in mind with hardware wallets and signing and making it more secure to keep your coins, and they might have thoughts on that point. It's a very interesting project. I think I can share the link here in the chat.
Thank you.
Yeah, I guess that's all I have to say.
Okay.
Thanks for organizing this.
You're welcome. Jesse, Nat, anybody else? Shannon, Wolf?
Yeah, I can jump in. Yeah, I'd just like to thank you, Christopher, for putting this together. It was a great idea. I think this has been fantastic, and would love to do this again, like others have said. In terms of how to convince developers to use Frost, I think to the extent that we can make our implementations batteries included, as Tim put it, where we can kind of provide ways of getting these guarantees around broadcast channels and authenticated encryption, so there's as few foot guns as possible, and the implementation is just ready to be used without having to think much more about it, I think is going to help developers feel like they can actually use this stuff safely. And the other thing is, I think these Shamir schemes, these extensions of proactive secret sharing, repairability, enrollment, and disenrollment, I think all of those add a ton of value to Frost. I think it adds a lot of cool use cases, and I think to the extent that, you know, once we kind of have these base implementations in a good shape, I think moving on to how we can layer on these additional protocols, I think will really entice a lot of users to want to use these systems.
Thank you.
Yeah, I'd like to chime in. Yeah, from the blockchain commons perspective, as I said, I'm not a cryptography person, so a lot of what you guys who are into cryptography, I respect a lot, but it goes over my head. But what I do see is value proposition in various things, and when we see, and as an engineer, when I see the value proposition in something, and when it's being handed to me, you know, batteries included, without, you know, with, you know, in general, and either told how to or prevented from using foot guns. I have a very good experience developing end user apps. And so my role in blockchain commons is often to take the kind of more the best practices that have already been identified with the cryptographic community, and then put them into a context where other engineers like me can say, oh yeah, this is definitely worth picking up and just using as is right now. And that's what we're striving to do. We're not big on so-called crypto agility, where we're trying to support every single cipher suite, every single you know, variant. We tend to like to establish, you know, one thing that the community has consensus on, as this is at least as good as anything else out there, and it offers unique value, and then package it in such a way that people can just pick it up and use it. So that's what I would like to see the output of this kind of roundtable, this kind of community effort being. And as a second tangent, I'd say if you work for an organization that would find this, that finds an ongoing kind of community development and development of specifications, reference code, and example apps, you know, because we don't publish final apps or wallets or things like that, but we do things that are completely open source that the entire community can access. Then please consider sponsoring Blockchain Commons, because I think it's a fair amount of bang for your organization's buck.
Thank you. Okay, well, I think everybody who is left has spoken up. Again, blockchaincommons.com has, you know, all of our documents. There is now a developer sub area, which will soon include a new Frost section. Have a kind of a Schnorr for the layman article out recently, and I'm working on a Frost for the layman. And obviously you can reach me a variety of different places: Signal, at Christopher A on a variety of channels. So if you have any questions, please reach out to me, and I hope that we'll have YouTube video and transcript and some other notes up, over today and over the next week. So thank you very, very much for joining us, and look forward to meeting again.
Thanks, everyone.
Thank you.
Thank you. Bye, everyone.
Thanks. Bye.
Thanks, bye.